presentation on the second part of the Near2Me field trials. This is N2M-MET, Metadata Enrichment and Tribler. How this works is we're doing tag team presentation. So I'm going to talk during the introduction, and then Rainer is going to tell you about the field trials, and then I'll come back to the conclusion. So if you're planning to do your literature, inputting your literature and tagging your literature, you can do that while I'm talking. I don't mind, but listen to Rainer. Okay, so basically, the introduction is my part. This is what we're doing right now. And then we're going to go through the 3 phases of the metadata enrichment and Tribler field trials. First of all, the first phase regards this nice term cloud within Tribler. You probably remember hearing about that in Berlin. Now it's been implemented, and Raina will give you a demo of that. And then we're going to talk about the presently ongoing phase 2, which is bundling of near duplicates. Sounds complicated, but it's really quite easy. It's grouping together semantically similar results in a search result list in order to make the result list more compact and more easily understandable for users. And then finally, an outlook towards phase 3, which is bringing together the bundling with the current ranking thing the ranking algorithm in order to create a better ranking. And then we'll go to conclusion and outlook. Okay, so my intro. Just to remind you how this hooks in with our Petamedia technical annex. Our field trials here are done within GPRA 4. And basically, our goal here is to validate the Petamedia triple synergy in field trials, and in particular, in this field trial, we're attempting to go for scale. So one of our key performance indicators in Petamedia is that we involve at least 1,000 users in field trial, and Tribler and the extensions that Ray has been implementing within Tribler gives us the opportunity to do that. Okay, so how do we get from those excerpts from the technical annex to actual software and field trials? So basically each phase has this basic structure, which I'll just run through. First of all, we talk to the Tribler team on the 9th floor and figure out from them where there's actually a user need that we can answer. And then we developed a triple synergy functionality, or triple synergy inspired functionality that answers the need. We say inspired because it's not always possible to use the full triple synergy. And then design an extension that will implement this functionality. The extension is implemented, but we also time our schedule with the Tribler release schedule so that we can piggyback on a major release of theirs, which guarantees more downloads of the client. And then in order to do the validation, we basically collect log data of user events, and we use them to gather statistics that allow us to see certain things about how users are interacting with the functionality. Okay, we operate under certain boundary conditions in the metadata enrichment and Tribler field trials. Basically, Tribler, as our colleagues on the 9th floor are fond of reminding us, is production level code, and that means that it's out there, it's being used in the real world with real users, and we must have very robust software. We also, as I mentioned before, must actually be addressing a need that exists within the community. The extension must be acceptable in response time and online. So it has to, and so yesterday when we were talking about OTBT, we were wondering about scale. Okay, we worried about that. Here we're worried about it. If it's not fast, forget it. And they're going to say, no, we can't release your extension It just doesn't do anything for us. It's too slow. And we also have to integrate into the basic roadmap that they have set up. So Tribler is going through this huge burst of development where they're integrating more social features, including channels, playlists, and now the bundling that we've been working on and looking forward some user-based re-ranking. And so the whole thing has to fit together into one conceptual whole that also makes sense for the members of the Tribler community. And also, another thing that we realized is that even although we have a pretty long field trial span, who want to go large scale, we don't have a lot of time to wait around for people to contribute metadata. We want to go as much as possible as a single shot experiment. Okay, so you'll see that with the network buzz. Basically, it was an extension that was implemented, and the moment the 5.3 was released on the 12th of December, we started collecting, or we were able to start collecting data concerning usage, and we didn't have to wait around and wait for people to tag. Oh, they're not tagging. What are we going to do? That's how it's set up. And finally, we have to be able to test the triple synergy aspects of the extension via log data that can be crawled from the network. So that also takes a little bit of planning to make sure that we do things that we can actually validate given the information that we have. Okay, so this is the maybe dry introduction stuff. I have a couple more slides and then we can get to Rainer. So what is Tribler? Just for those of you who might not know, basically, well, it's a community. It's a peer-to-peer community. In more technical terms, it's a BitTorrent client, and it uses a semantic overlay. And it means that within the peer-to-peer network, you're not just related to people that you exchange with, but you're related to people that you exchange that have semantically similar habits as you do. So it has this awareness of the content that you're actually exchanging. So in a way, it goes in the direction of a content-aware network. It is also 100% server-free, and this is the point that I want to really emphasize here. That whatever we do in Tribler is going to be automatically at least 1 or 2 orders of magnitude more difficult than in a server situation. The individual peers can only ever talk to each other, and they never can go home and dock on the mothership and get information from the central source. So that makes things, for example, like the term cloud. Well, actually, we thought the term cloud was perhaps impossible when we started out, but Rainer will tell you that story. But anyway, the 100% server-free part makes everything that you hear Rainer talking about extremely difficult. Tribler has been used by this morning statistics, right? As of this morning, it has been downloaded and installed by 796,922 peers, and so some statistics. Okay, so we're getting some nice exposure there with our Petamedia extensions. And I give the floor now to Rainer talk about the phases.
Okay, so the first phase, network bus term cloud. So this phase was mainly motivated by some informal observations we did. This is an example. Comment on new release of Tribler where it says, I just tested this out and it sucks. Even a quick search for Lady Gaga gave me no results. So it's not a very positive comment. When you see that on the internet, you're like, So what's actually the problem? Well, apparently the user does not understand Tribler, and that results in unfair expectation. For the user, it's basically just a black box which the user is interacting with. So how do we solve this? Well, we don't solve it like this. It's not a solution. We cannot say, well, please read this nice book on computer networks, get a degree in computer science, and you will understand how Tribler works. So that's not an option.
Why not? This is what
Why not? Well, yeah, we could do that, but I think
we want to educate people. Yeah, exactly.
Well, it would save cost on support. Help desk for users that say, oh, Tribler is not expert users, but that's not the target audience, right?
We need 796,000 people with a computer science degree.
Yeah. So this is not going to work. So what is a solution? Well, the user needs experience or a surrogate for the missing experience. And during the first phase, we developed the network bus, which is an evolving network term cloud, and we hope that it would be the surrogate for this missing experience. So the network level term cloud. So what's the relationship with the triple synergy? Well, it's only using the two legs of the triple synergy, the social annotations and the network structures. The terms used in the term cloud are extracted from the file names. The file names are originally provided by the user. And the network structure, the discovered content. Alright, so the displayed term cloud has a bias towards content that's similar to what the user has previously downloaded. So if you're into a specific kind of content, then your term cloud is more likely to go towards that particular kind of, to show terms that are more related to that particular type of content. So as I said, only two legs, so no multimedia content analysis. So this is a slide also from Berlin, so this is a reminder how to make a term cloud. Well, it's the usual stuff, some term extraction, filtering, and visualization. But network bus is slightly different, and that's what will be shown in the following demo. If I can, right. So, okay, this is Tribler running live. So at the bottom, when you start Tribler, at the bottom there will be the network bus that will show this term cloud. And as you can see, there's a count here, so it's evolving. It will display different terms every time. And if you're interested in some content, you just, I need to find my cursor, just click on anything. Are there any suggestions on which one I have to click? No one, or should I just pick one? Which one? Currently it's frozen because my cursor's here.
Top chef.
The year.
Jobs. Okay. Oh, if you click on it, then there will be results showing, and oh yeah, the user can then continue on by just clicking on the result and download it, but I won't do that right now. So let's go to the network bus panel again. So originally, if you have this client installed, just freshly installed, then this will be kind of empty, and it will slowly start growing because more and more content is discovered. And we hope that kind of effect will help the users also kind of understand that how Tribler kind of works, that it's not something like Google where everything that's on the web is there. So that's the feeling we want to convey to the user. Tribler is evolving. Even your own client, it's not static, it doesn't know everything, it's continually growing and evolving. So that's for the short demonstration. Let's go, let's get rid of this and continue on. So Network Bus has been deployed in Tribler 5.3, which was officially released on December 8th. We currently are gathering the user statistics, and our initial observations are the following. More than 4,000 peers have used the network bus so far, and it resulted in more than 30,000 clicks on 2,700 unique cloud terms. So these results look promising, but we still have to do further analysis with the interaction with the feature. So which clicks do or do not result in downloads, for example. So it's nice that the users click on the network bus, but as you have seen just now, I just clicked on top stuff, but I didn't download. So that kind of behavior, you have to check that whether there are a lot of users that do that, or there are a lot of users that actually then download stuff. So for the first phase, our research question 0 is, well, can we evaluate the learning effect of evolving network term clouds using crowdsourcing? So why did we have this question? Well, the problem is with just Tribler and the usage logs, we cannot measure the effect, the learning effect of the term cloud. So we needed some other setup, and also a lot of users. So crowdsourcing was the answer, but we didn't know whether it was actually possible to do it. So we had first this question, and the answer is yes, but you need to make sure that your task is properly designed, and of course it does not require you to download Tribler, because that's, if you first need to use it to download Tribler to do the task, that's, you might as well choose a different approach to measure it. So, what is crowdsourcing? I'm not sure if anyone knows what it is. Has anyone never heard of Amazon Mechanical Turk, or? Okay, well, so Amazon Mechanical Turk is a platform for crowdsourcing that makes it possible to have these small tasks that you can offer, and then other workers, or sometimes called Turks when it's about Amazon Turk, can then perform. Usually these tasks are small, so that a lot of users can do a lot of them in a sequence, so they can, let's say, do tens to hundreds small tasks in a row. Depends, of course, on the size of the task. And also possible with Mechanical Turk is that requesters can assign qualifications. So we could say, well, we don't want everyone be able to do our task. We only want qualified users. So we can first assign qualifications to certain workers that have proven themselves to be delivering high quality answers, and then have subsequent tasks that are only available to those workers. So, the more interesting resource questions, or resource question 1 and 2. The first question is, can we generate network level term clouds at individual pairs with sufficient coverage and speed, and can users learn from evolving network level term clouds? So, the answer is fortunately yes to both. The second question we answered using another Mechanical Turk experiment. For the first one, we just ran 30 Tribler clients and just measured, well, which terms are accumulated at each pair, and then see what are the differences between each pair. And the bottom line is what they have in common, and the other lines show the disparity, and we found that disparity is tolerable. So yes, we can have term clouds that only use local data.
So how many terms are discoverable at all? Because the vertical axis ends at 3,000. So is it
sure? How many weeks? 700 hours? Well, I'm not sure if there's an actual. Possibly there is a limit, because each, well, you have the natural language that has a maximum number of words. There are particular series and shows and whatever on the internet. So there is certainly, I think there is some ceiling, but I really have no idea how many terms there are. So
for example, in TrackFit, if I might say, in medieval, I can jump it. There are 400 videos from Whale and Cloud documentaries, something like 30-some thousand different terms.
Oh, okay. But so, first of all, we don't know whether these are going to fit typical natural language word distributions. And second, the content is very dynamic here. So basically, we don't really know if this levels out or not.
Well, it certainly will eventually level out, but the question is, of course.
Yeah.
The
point is.
Wondering about that data set. Is that all terms, or is that filtered? Or
all terms. When I indexed it, so there are like 32,000 without stemming and something like that. We have 32, let's say, on top of my head, 1,000 different unique.
We're trying to fit it into the available space on the memory card.
No, it's fine. So that's
Okay.
because in this particular example, I did some filtering, if I recall correctly. So certain terms are just
Yeah,
removed.
but it's still not natural language, so you can't even compare it. Even if you
yeah.
say you filtered in both cases, it's still not comparing apples and oranges.
We'll have to run more clients for a longer
Yeah.
time, but
Yeah.
the problem was that the server we ran it on at one point.
Okay, so the question, the reason why I'm asking is that these curves don't show any saturation effect. They seem to be fairly straight lines with a certain gradient. Can you explain why the gradient is like this?
Well, the gradient is okay.
So, alright, so yeah.
So Marta says yes, but now the answer.
Now, I'm not sure if I can explain the gradient, like why it's this shape. It's true. The only thing I can say is that the torrents that are discovered from which the terms are extracted are growing at the number of torrents collected are more or less growing at a particular rate because you are only collecting torrent files from peers at a specific interval. You're not going to download everything in one go, but I'm not sure if there's any explanation between.
That must be a consequence of the protocol being run for exchanging this type of information or file names, since this is derived from file names, etc.
The only thing that is remarkable is the beginning, where the users downloaded more torrent files in the beginning, and then it's more steep. But other than that,
Okay.
any other short?
We don't know because we don't know anything about the properties of the kind of language that's there. The point is that, right, the disparity between them, there's not a large difference between these lines.
The terms that are
the single
not
peer will track the intersection of all peers. That's the point about this, what this side. I mean, we can also look
I
at other
understand.
things that don't really necessarily impact the cloud.
No, I understand that the experiment has a different objective than the question that I
Yeah.
asked.
Yeah.
Okay. Yep.
I only want to ask if there are any stop word filtering, because I saw in your cloud there are so many useless tags like MP3 or video.
Wait, why are they useless?
Because
That's a question. about whether
MP3 is a very well-known tag, but okay, if I click on it, there are more than millions of files.
True, but we have seen users actually clicking on them. So
Yeah,
there are
it's okay. But
Whether it's used for the actual user, or at least it's a learning experience
But
for the
this
user.
means there is no stop word filtering.
Oh, there is some stop words filter, but
Okay.
not. It's using the English stop words list and very short term, so like 2 or 3 characters. I'm not sure. Those are removed.
Okay.
So the second phase, bundling your duplicates. So in the second phase, the problem is that Tribler results lists are most of the time way too long, and that makes them difficult to interpret at a glance. So that's a screenshot, so it's not very clear to see, but this is a particular example with the query heroes, and there are 141 results. So the user has to scroll through them, so that's not that user friendly. So the solution is to bundle near duplicates, so grouping similar items in that should have been results, I think, and hiding duplicate results, and also demoting incidental matches. I'm not sure. No, that was not visible in the demo I gave earlier when I clicked on the term in the network bus. But sometimes there are results that are that match the query somehow, and Tribler uses very rough way of matching items to the query, and with bundling these incidental matches will probably not be grouped with other items, so they will be ranked lowly in the results list. So the research question here is, well, we need an answer to the following research question. When do users think that two terms are the same? Because we want to bundle, so we want to bundle things that are similar to each other. So in this example results, these are 3 items, Pioneer 1, Episode 1, and Episode 2, and the complete first season. So, well, these items are similar because, well, the first 2 are from the same series, and the first 2 are contained within the third item. So, how are we going to answer this question? Well, we just ask the crowd again. We just present the workers a task where they have to say, well, here are 3 files, please say why they are the same, different, or whatsoever. And the most important thing is why they think something different, why some particular file differs from the other. And the results from that experiment is the following. We went manually through a large list of answers from the experiment, and we categorized them into 44 user-perceived similarity categories. These are not, of course, all 44, just a few of them. So let's pick one. So user said, well, this item is different from these 2 because it's a completely total different movie, or let's see, well, this is a full season of a series, and these are just 2 single episodes, so there's a difference there, and there are many more differences. So this is needed for the following. So the bundling algorithm should emulate the user's notion of similarity and be based on simple generalizations, so that those generalizations can be propagated through the network. So what we needed for the bundling is, well, various grouping functions and various conditions on which the particular and most appropriate grouping function is selected. And what is also needed, and it's quite important, is that user click, so the behavior, the interaction of the user with Tribler should reinforce useful functions. So if a particular grouping function is selected for a particular results list, then if the user does not like it, he should be able to indicate that, and well, and through that interaction we should extract the information which grouping function is more appropriate, and that information should then be propagated to the network. So research questions 4 and 5. So is it actually useful to bundle semantically similar results? And is it useful or helpful to propagate popular bundling generalization through the network? And for these we will use again Tribler's interaction logs to answer these 2 questions. So triple synergy. So what's the relationship? Well, currently, again, currently only 2 legs are used, which are well, the social annotation is the same as the network bus feature, but the network structure, well, the useful functions are propagated through the network. The problem with multimedia content analysis, it's not practical as of now. We can only do very simple things like fastest on bitrate. Those are practical, but we might expand that to also thumbnail extraction and analysis of these thumbnails. It's are things we have to discuss with the Tribler team. We think that it's something that can be done without without going outside the boundaries Marta discussed in the beginning of this talk. So the next phase is about better ranking. But first an intermezzo, what the Tribler team has done so far. So
but before you go here, so the innovation, the phase that you just presented is currently being programmed, right?
Yes, the second phase.
This phase.
It was also what Marta said
Yes.
in the introduction. This is what's being worked on currently.
Okay. So what is your planning for that phase? Is it a matter of weeks, days, months?
I think Marta has a slide at the end for the.
Okay,
planning.
then I'll shut up. Okay, good.
So, short intermezzo. Tribler team has been working. This was implemented in the beginning of Near2Me. Well, channels were introduced in the 5.2 beta version, and now it's actually becoming quite popular. It's being used by users, and this is a screenshot from a few weeks ago that people start voting on channels and sharing stuff in those channels. And so that's a good thing. This means that we can use that for the third phase, hopefully. And what's currently in progress is, or heavily in progress is open to edit, which is file name piping within channels. So let's return to the Near2Me MET phase 3. So better ranking. So the current ranking of Tribler needs to be improved, and of course then thus address the ranking of bundles, since in phase 2 we will be introducing bundles, and a better ranking algorithm should then also deal with the problem of ranking bundles in that resource list. We must integrate, well, since the Tribler team is working on open to edit, it should then also deal with PIM file names, and it should also incorporate the authority of a particular channel. If a results, an item results list comes from a particular channel. And for this third phase, our research question is: will bundle-aware ranking outperform Tribler's current ranking? So, it's time for the conclusions and outlook.
So how do you want to test that last question? Also Marta's slide.
No, the ranking.
Yeah.
Well, not the ranking, but whether it will
whether it will
outperform.
outperform.
You certainly get different results, but will it be better? That's the question, right?
Yeah. So it will be tested by examining the user event logs,
Yeah.
and this is dependent on whether we can get the client to log the things that we need it to log. So we have to know that first. But if it's able to save at least the top, N results that are associated with the query, we can compare the top rank of the first clicked result
Yeah.
between the two different rankings.
Okay, so that's the way
Yeah,
you would do this.
that would be
Top
that
rank,
would be the
average rank,
simplest-
whatever. Yeah.
Right, the simplest way to do that.
The only problem with that is that we just make sure that for the newer or the better ranking that we certainly store all the required information that is fed into the better ranking algorithm, because that
Yeah.
information might vary, of course, at the pair level.
Yes.
But there's also, of course, for the current ranking algorithm, that also depends on local information.
Yeah.
So we need to make sure that when we are going to answer this question, that we instrument Tribler with enough logging features that that kind of information is stored.
Just out of curiosity, Marta, as you said, this is a fully distributed system, no server, 100% server free. Of course, when you do logging, there is some server involved, right? So these clients do dock in the mothership every now and then, or is this a wrong assumption?
I think Rainer's
Should
very
I-
happy about this question.
So the question,
How is it done?
well, how is it done is one thing, but the question that I wanted to ask is: are the users aware that their behavior is being logged?
I'm not sure if the users are aware of. That's a different.
That's a no to me.
That's a different question, but the way it works is when you install Tribler, well, the thing is, of course, Tribler is hosted on the internet, so completely 100% server free, kind of depending on the definition. But Tribler itself, when you install it, it's shipped with a text file which contains kind of identifiers. And Tribler client will only listen to requests to this particular crawling request where we say, please give me some kind of information about your click behavior or your, I don't know, full dump of your database, anything. And we'll only do that when you can prove that you are one of that, well, those identities that are in that list. So if I just
So
take
there's-
any Tribler client that tries to ask another Tribler client, please give me all your data, then the other Tribler clients
Okay, so there's
your
a
ID is as well, you're not in the authorized list. But the user can also, it means that the user can empty that list and then just don't respond to any
okay.
message at all. But it
So there is some authentication going on here.
well,
When,
it's public private key cryptography.
I understand.
So it's distributed. It's just that that initial list is provided when you download the client and install it. But the crawler itself, anyone can start a crawler as long as he manages to get the
valid keys.
right.
Okay.
So
And to my first question, so the user is most likely not aware of that.
I'm not sure if it's actually anywhere on the website or it's. We should ask perhaps the users whether they.
Okay.
Well, I mean, I just installed the new version this morning, and I just agreed to the conditions without reading them. So
yeah.
probably I should have.
The condition list is quite long, or the yeah, it's quite long because there are different kind of software licenses also listed. So it's BSD, GPO, whatever. It's a long list, and also different universities and institutes are mentioned. So no one is going to read that. So I will return the floor to Marta. If there are no questions, so we can continue with the last few slides.
Okay.
Good.
So, just to summarize and give an outlook. So the phase one, which has been complete. Yeah, basically we're happy to say that we've achieved our goal of involving at least 1,000 people in the field trial. That was a relief when we saw that we were reaching that many users. And so right now we're logging, and we need more time to log to have a nice period of time to get some good statistics out of that about the cloud, and be able to do analysis of the logs. And so phase two is we have duplicates. It's underway, and we're aiming for release in the next big release, which is the 5.4 release. And we went downstairs and asked a similar question, like, can you give us an idea of the schedule and when? And we got the answer that it's going to be about the beginning of May, and that fits with us with two. Right now we actually. Well, Rainer might have a slightly different opinion, but we have kind of a real estate problem with the interface, or challenge, let's say, because you noticed that was a pretty small interface. So we have to make sure that with the bundles, we don't try to pack too much information into that. So we have to make sure it's displayed in a way that makes sense, but does not overcrowd the interface. So that's a bit of a challenge, and also to choose exactly the right functions and conditions to use, but we're narrowing it in on that, and I think we'll be good to go in 5.4. And of course, what you said, the instrumentation for the logging also has to be in place.
Is that going to be an option for the user, which type of bundling to choose? Because you said 44 dimensions, so...
No, the thing is, we might not be able to do all 44. But
Okay.
we want to at least try to cover a few of them with the functions.
But nevertheless, so even if you have a few, is that an option for the user then? To say, oh, I want bundling according to this and this criterion. So for me, different qualities count as, same content.
Right, so the idea is that, well, one at least is big, and the system will try then to pick one that it thinks is best, but user will be presented an option to say, just give me some, try to reorder the list, and then it will present different.
Different bundlings.
Yeah, and you can cycle through those.
And at some point you said you figure out which are the more popular ways of bundling, and you would propagate that through the network. What does that mean?
So if the user cycles through the different bundlings and then clicks on a particular item to download, then we would infer that as a useful bundling.
For that particular item.
Or query, or there are different kind of...
Or for that particular user.
True, so that's information that needs to be propagated. We need to know, well, for example, query might be a useful information. Characteristics of the whole resource list. So, are there a lot of small files? Are there a lot of large files in the resources? Are there any particular structures in the file names? Like, are there a lot of digits in each file name? Or so, all kind of statistics on the resource list should also be used and propagated and coupled with a selected user function.
Okay.
And when it's propagated, that should then be fed back into the algorithm that picks the initial bundling.
And we think that we can transcend personal preference because we did this user study on Turk where we identified these 44 different dimensions, and we're focusing on the main dimensions of user perceived semantic similarity, which transcends in individual preference. For example, series media, people say, okay, these two episodes, they belong to the same season, and there it's pretty clear that series media, you want that grouped in a different way than, for example, songs that are by the same artist. So we're trying to automatically detect the difference between these two classic cases and apply a universal bundling function. And once we figured that out, then that gets propagated. Probably just repeated what you said, underlining the fact that it's not a personalized system. It's trying to propagate what is useful for everybody.
Okay.
Okay, we have one more slide. Oh yeah, okay, so, and then, no, so then phase 3, the better ranking. Well, here we want to do at least a proof of concept for MCA. I'm still saying that this is a bit ambitious. We want to be very careful about promising this because of the difficulty of doing any calculation on the peer. But apparently the Tribler is moving in that direction for streaming. They already have to do some calculations like bit rate and stuff.